Hey, what's up, guys? Today, let's talk about the solution 2 of the Lintcode problem number 13, string. In last video, we talked about the solution 1, and today we talk about the solution 2 using the Robin-Karp algorithm. What is Robin-Karp algorithm? Actually, the whole idea about this Robin-Karp algorithm is that we convert the strings comparison to the integers comparison. Because previously when we compared two strings, if the average length of the string is n, and at least we have to spend on time to compare. But if we can convert these strings to a unique integer, then when we compare these two integers, it's going to be always O1. So that's how the Robin-Karp can help us to improve our time complexity. Let me just emphasize that again. Robin-Karp algorithm is all about convert a string to an integer. Convert strings comparison to integers comparison. So previously, in our previous algorithm, we have to use on squared, but now we can just use on. Right, let's look at the code for detailed information. First, we're going to just have to do a input parameters, checking if the source is none or target is none, which is a return a negative 1. If the target is empty string here, which is always return 0. Then we're going to have to get the length of the source and the target. The source length is n, target length is m. Then we initialize the target hash and the source hash in the base. What is target hash? When we're talking about that, convert the target string to a integer, we call this integer a hash number. This hash number is an integer. Same thing for the source, we have a source hash. And also for the source hash or target hash, they cannot be like an infinite large number, so we have to give them the space. So here we just give them a base, which is the 10th power of 6. Because they have a limited space here, so it may, because this hash, right, it may got the conflicts. So later we're gonna resolve those conflicts. So conflict is not a problem. We can still use Robin-Karp to resolve this problem. All right. So then this part of code is to calculate the target hash. Like we calculated before, target has m length. So we just loop through this target hash, and we get each target characters. We convert it to the target hash. How do we do it? We just use the target hash multiplied by 31 and plus the target i's Oxmark code, and we just modulate it to the base space. Let me give you an example. For example, we have a string of ABC. So this is how we calculate the convert this string to a number. A's Oxmark code is 97. Then divided by 31. And 31's power of 2, and 98, which is the B's Oxmark code, multiplied by 31 and plus 99. So it's kind of like familiar. If I make it to 10, it becomes a decimal, right? If I make it to 16, and here 16, it's become a hexadecimal. So here we just use 31. 31. Why you use 31 here? 31 just is a good number. Can reduce the conflicts in the space. So that's why we use 31. You can use some other numbers like 33. It's all fine. All right. So this part, I think you understand that. And also, and then here we use another for loops. And this for loop is gonna just loop through each characters in the source string, and we're gonna calculate dynamically calculate the source hash. And source hash, same way, the source hash multiplied by 31, and plus its argsmart code, and modulate to the base space. Here we need to check if the JJ is the index, if this index less than m minus 1, and we just continue calculate this hash. What does it mean? That means when we calculate the source code, for example, this is the source, this is the target. When we calculate this, the hash of the source, we calculate A, and we just continue calculate A, we continue calculate B, and at this time actually we already calculated the 3 characters, and our target is length is 3. So before we reach to a 3, we just always calculate. So that's why we just always continue. After we reach 3, we can start to do the comparison here. But what if we reach the beyond the 3, beyond the length of the target? What are we gonna do? Obviously, we have to minus the leftmost characters hash. That's what this part is doing. So you understand this part. So let's see what does this part do. If this j greater than m minus 1, that means we calculate the over the size. So we need to adjust the source hash. So our source, the current source hash, we have to minus the leftmost character. This is the leftmost character. J current index minus the length of the target. This is current index. And we need to calculate the hash. This hash is 31's power of m. All right. So the current hash minus this and modulate to base, then we get this desired hash, source hash, what do we want. And after this hash is calculated, so we're gonna just compare this source hash with this target hash, because they're integers, so easily to compare. If they're equal, like I said before, they're a hash. There may exist some conflicts. So we cannot just fully trust this this hash. So even the hash they're equal, we still have to check that we have to check the source string to check if they are the same. The source string is j minus m plus 1, and the end index is j plus 1. This is the slice of the array of Python, and we check this source string part of the source string if they are equal to the target. If they are, that means we found one. So we just return this index. All right. If we didn't, we just return minus 1. So sounds great, huh? All right. So let's try it out. Right now, I'm trying this one. Yeah, looks like everything is fine. Thanks. That's today's algorithm.